Good morning, everyone. Let us start this session. So, in the last session, we have seen the problem on the block friction. Okay. So, this problem it is for the connected blocks. So, we have to determine the force P required to produce the impending motion of the block B down the plane, and weight for the block A is 500 Newton, and for the block B it is 750 Newton. Okay. So, here two blocks are connected by this cable, and this cable is passing over the smooth putty. Okay, and the inclination given for the plane, this is 30 degree and this is 50 degree, and coefficient of friction, that is a static friction, is 0.3 for the block B and this inclined plane, and 0.4 for the block A and the inclined plane. Okay, so question is we have to find out the force P required so that the impending motion for the block B, it will be down the plane. Okay, so this is the direction for the impending motion. So if you want to produce this impending motion for the block B, then impending motion for the block A, it will be in the upward direction along the plane. Okay, so you can observe here. So if the block start moving, then this is the motion. Okay, so this is complete dynamic state, but we have to find out the force P only for the impending motion. That means it is the limiting point of the equilibrium. Okay, so from this impending motion direction, we will draw the free body diagram. So consider the block A. So for this block A, the impending motion is up the plane. So this is the direction for the impending motion. Okay. Now we will show the forces on this block. So first is the weight, and it is given as a 500 Newton. So this weight, it will act from this point exactly in the downward direction. So this is equal to 500 Newton. Then second force, it is the tension in this cable. Okay. So this tension will be same on other side of the pulley. Okay. So this tension we will assume as a T, and exactly it is parallel to the plane. So this is the tension, and there will be normal reaction which is perpendicular to the inclined surface. So this is the normal reaction. Okay, so as the impending motion is up the plane, the frictional force will be exactly opposite to the impending motion. So this is the frictional force, and this force, this is F max. Okay, so there is no other force. Now assume the reference axis like this. So this is y axis and this is the x axis. So try to resolve the forces which are inclined with this reference axis. So if you consider the reference axis, so this dotted line, it is for the plane, and this angle is 50 degree. Okay, so here the tension F max, they are exactly parallel with the x axis. So no need to resolve these forces. This normal reaction is along this y axis. Okay, so no need to resolve the normal reaction. So just we have to resolve this 500 Newton. That is the self weight. Okay. So for this 500 Newton, we can resolve the force at this point. Okay. So draw one component parallel to x-axis. So this is the x component. Second component parallel to y-axis, like this. Okay. Now this y component, it will make the angle 50 degree with the 500 Newton. Okay. So now you can write this component. So y component is the adjacent component. So this is equal to, this is 500 cos 50. And this x component, this is 500 sin 50. Okay, so in this way you can draw the free body diagram. After this, write the equation summation Fy is equal to 0. So for summation Fy, we have the normal reaction in the positive y direction. Then this 500 cos 50 in the negative y direction. So minus 500 cos 50. Okay, so only two forces in the y direction. So this is equal to 0. So from this, we will get normal reaction n is equal to, this is 500 cos 50. Okay, so after this, use the equation summation Fx is equal to 0. So for summation Fx, we have this tension on the negative x side. So observe this reference axis. So minus P, then this F max on the positive x. So this is plus F max. Okay, and then 500 sin 50. So plus 500 sin 50 equal to 0. Now F max value, this is the limiting frictional force. So this is equal to coefficient of static friction into normal reaction. So this value is given. So when we consider the block A, coefficient of friction is 0.4. So this is equal to 0.4 into normal reaction. So put this value in this equation. So replace the F max value. So minus T plus this 0.4 into normal reaction plus 500 sin 50 and equal to 0. Okay. Now put the value of normal reaction in this equation and calculate the value for tension T. So tension T, this value is equal to 511.58 Newton. Okay, so just check the answer. So by considering the free body diagram for the block A, we can find out this common value, that is the tension. Okay. So when we consider the free body diagram for the block B, it will have the same tension value. Okay, because this rope is connected to block A and the block B, and tension on both the sides will be same as the pulley is frictionless. Okay, so it is the same T on other side. Now consider the free body diagram for the block B. So for the block B, its weight is given, which is equal to 750. So from this point, weight will act exactly downward. So this is 750. Then there is a normal reaction. So this is normal reaction. Okay. So I will consider this normal reaction as a NB, and here it is a NA. So your first value is NA, which is 500 cos 50. Then we have this tension, and this tension is exactly parallel with this inclined plane. Okay. Then this is the external force P, which is to be determined. And the impending motion for the block B, it is in the downward direction. So the frictional force will be exactly opposite. So this is the frictional force. Okay. And this frictional force is the F max value. Because when we consider the impending motion, it is nothing but the limiting condition. So we have to consider the limiting frictional force, which is the F max value. Okay. Now here we will consider the reference axis like this. This is parallel to the plane, which is the x-axis, and this is perpendicular to the plane, which is the y-axis. And resolve the forces along this direction, x and y. So T and this F max, they are parallel to the x-axis. So no need to resolve these forces. Even force P is also parallel to x-axis. NB is parallel to y-axis. So we have to just resolve this 750 Newton. Okay. So we can resolve at this point. So draw one vector parallel to x-axis and second vector parallel to y-axis like this. Okay. So if we extend this line, then this is the plane, and with respect to this horizontal, this angle of the plane is 30 degree, and therefore this y component of 750, this angle, it will be 30 degree. Okay. So you can write this component. This is equal to 750 cos 30, and this component, this is 750 sin 30. Okay, so in this way you can resolve the block B or the forces on the block B. Now use the equation, which is summation Fy is equal to 0. So for summation Fy, the first force is a normal reaction NB in the positive y direction. Then we have this 750 cos 30, that means this component in the negative y direction. So 750 cos 30. Only two forces in the y direction. So this is equal to 0. So we can write the NB. This is 750 cos 30. Okay, so after this, use summation Fx. So for summation Fx, this force P, which is the external force, it is on the negative side of this reference axis. Okay, so it is a minus P. Then this tension is on the positive side, so plus T. Then this F max, it is also positive, so plus F max. And this X component, which is 750 sin 30, it is negative, so 750 sin 30 equal to 0. Okay, now in this equation, we know the value of tension T. This is 511. F max value mu s into n. So this is for A. For B, this F max value. So coefficient of friction is 0.3 into normal reaction, which is a NB. So you will get the equation minus P plus tension is 511.58 plus this is 0.3 into normal reaction NB minus 750 sin 30. Okay, so from this equation, put this value of NB in this equation and calculate the value of force P. So you will get the force P as 331.44 Newton. Okay, so you can check this answer. Okay, so note down the next problem. So here the block A, it is kept on the block B, and A is having the weight 20 kg and the weight of B is 30 kg. Question is, we have to find the force P required to pull the block B. Okay, so we have to find out the force P and the coefficient of friction at two different contact surfaces. One surface is between block B and this ground. This friction is 0.25, and second contact surface is between block A and block B. So at this contact surface, friction is 0.3. Okay. So these two coefficients, they are static coefficient of friction. So mu S for A and B, this is equal to 0.3, and mu S for B and ground, this is equal to 0.25. Okay. So for the free body diagram, we need to isolate the block A from the block B, and we will draw two separate free body diagram, one for A and second for the block B. So for the block A and B, we have to decide the impending motion. So as we want to pull the block B by applying the force P, that means the impending motion for this block B, it is towards right side or along positive X direction. Okay. So we can show the impending motion for this block. So this is the impending motion. This is the external force P. Then at this contact surface, the ground will offer the normal reaction. So this normal reaction is NB. Okay. And there is frictional force which will oppose the impending motion. So at this contact surface. So this is the frictional force. And this value is at max. And this is equal to mu S into normal reaction NB. Okay. So this coefficient of friction, this is 0.25. So it is 0.25 into NB. Okay. Then for the block B, it has two contact surfaces. So first contact is between the block B and the ground, and second contact is between block B and block A. Okay. So there will be second normal reaction at this contact surface. So this reaction, it will be same for the block A. So this is the common normal reaction. So this will be normal reaction NA, and it is same for block A. Just direction is opposite. Now at this contact surface between block A and block B, what is the direction for the frictional force? Okay. So friction will be exactly opposite to the impending motion. So the complete block B is moving towards the right side. At both its contact surface, the friction will be opposite to the impending motion. So this is the friction force direction at the second contact surface. Okay. This value F max is equal to mu S into normal reaction A. Okay. We have to consider this normal reaction. So this is equal to coefficient of friction is 0.3 into normal reaction is the N. Okay. So 0.3 Na is the friction force at this contact surface. Okay, so this is complete free body diagram for the block B. Now consider the block A. So normal reaction we have already shown. Sorry, one force is remaining in this free body diagram. It is the weight of the block B, which is 30 kg. So it will act exactly in the downward direction. So this is 30 into 9.81. You have to consider the force in Newton. It is given in kg. So 30 into 9.81, it is the weight force. Now consider the block A. So for the block A, it will have the weight force, and this is equal to 20 into 9.81. Weight is 20 kg. Next, we have this rope connected. Okay. So this rope, it will have the tension force when we pull the block B on the right side. So this tension force, it is directed away from the block A in this direction. So this is the tension. Okay. And in this angle is given in the problem. This is equal to 30 degree. Okay. Now at this contact surface between block A and block B, there will be friction force. So what is the direction of friction force for the block A? Okay. For B, we have shown the friction exactly in the opposite direction to the impending motion. Okay, because impending motion for the block B is towards right side. So what is the impending motion for this block A? So here we have to observe the relative motion. So this is the block B. We are applying the force P. So the motion of block B is towards right side. So relative to block B, this block A, it will have the opposite motion. So this is actually a relative motion. Okay. So physically, block A, it will remain at its position. It will not move because it is fixed by this cable. But if you observe the relative motion, then the relative motion of the block A, it is in the opposite direction. So this is impending motion for the block A. So we can show that impending motion for the block A. So this is the impending motion. So block A is moving towards negative x direction relative to block B. Okay, and depending on this impending motion, we can show the friction force like this. Okay, so this friction, it is same 0.3 into N because the contact surface is same. So this is equal to 0.3 into normal KFC. Okay, so this is complete free body diagram for the block A. So once you draw the free body diagram, next you can use the condition of equilibrium. So consider block A. So for the block A, with summation Fy is equal to 0. So before that, we have to resolve this tension. So you can assume the reference axis like this. So just tension T is inclined. So you can resolve this force. This is Y component and this is the X component. Okay. So X component is T cos 30. Y component is T sin 30. Okay. So for summation Fy, we have the normal reaction Na, positive Y direction. This weight force negative Y direction. So minus 20 into 9.81. Then this Y component of tension. So plus T sin 30. This is equal to 0. Okay. So from this you can write Na plus T sin 30. This is equal to 20 into 9.8. Okay, so this is your first equation. After that, use summation fx0. So for summation fx0, we have this 0.3 Na on the positive x side. So this is 0.3 Na. Then this x component of tension, which is a minus T cos 30, only two forces in the x direction equal to 0. So this is your second equation. Okay. So in your calci, solve these two equations simultaneously and get the value of normal reaction NA. Okay. So after solving the equation, you will get NA. This is equal to 167.235 Newton. And the tension T, this is equal to 57.93. Okay, so we need the normal reaction NA for the second equation because it is the common value of the reaction. Now consider the second free body diagram. So FBD for the block B, write summation Fy is equal to 0. So for summation Fy, we have this normal reaction NA in the negative y direction. So minus NA plus this NB and this weight force, which is a minus 30 into 9.8. Only three forces in the y direction. So this is equal to 0. Now here NA value is known, which is equal to 167.235. So you will get NB. This is equal to this NA on the right side will become positive. So this is 167.235. Then this 30 into 9.81, it will become positive. So plus 30 into 9.81. Okay, so from this calculate the value of NB. So from this calculation, you will get this reaction NB. This is equal to 461.535 Newton. Okay. Now write the equation summation Fx is equal to 0. So for summation Fx 0, consider this 0.25 NB in the negative x direction, 0.25 NB. Then this force P on the positive x side, and this friction 0.3 NE. It is also on negative x side, and this is equal to 0. Okay. Now put this value in this equation, and NA value 167. Okay. So from this you will get the P is equal to this 0.25 into NB 461.535 plus this 0.3 into NA value, this is 167.235. Okay, so solve this equation and get the value of required force P. So this force P from calculation, this is equal to 165.55 Newton. Okay, so check this answer. So if you apply the force P on the block B, which is equal to 165 Newton, then the block will be on the verge of motion. Okay. And after this, even if I increase the force by 0.1 Newton, then the block B, it will start its motion. So it will enter into the dynamic state. Okay. At this point, it is the limiting condition for the equilibrium. Okay. So this is your final answer. P required to pull the block B.